So next is a classification of the material. So when we look at the content of this textbook, so we can understand the three basic categories. That is metal, ceramics, and polymer. And in addition, there are the composites that are the engineered combination of two or more different materials. And after that, semiconductors, biomaterials, smart materials, and nano-engineered materials appeared. So when we say materials, so first, metal, ceramic, and polymer. And next is composite materials. And next is semiconductor, biomaterials, smart materials, nano materials, so on. Metal are composed of one or more metallic elements. Iron, aluminum, copper, titanium, gold, nickel, and so on. And often also non-metallic elements, carbon, oxygen, relatively small amounts are mixed together. Atoms in the metal and their alloys are arranged in a very orderly manner and are related to dense in the comparison to the ceramic and polymers. With regard to the mechanical characteristics, this material is relatively stiff, strong, and yet ductile, and are resistant to the fracture, which account for their widespread use in the structural application. Metal is strong, stiff and strong, and ductile. Metallic materials have a large number of the non-localized electrons. That is, electrons are not bound to the particular atoms. Many properties of metals are directly attributable to these electrons. For example, metals are extremely good conductors of the electricity. So in the case of the metal, electrons' behavior is very important. Next is ceramic. Ceramics are compounds between the metallic and non-metallic elements. They are most frequently oxidized, nitrosized, and carbonized. For example, common ceramic materials include aluminum oxide, silicon dioxide, silicon carbide, silicon nitride, and in addition, some referred to as a traditional ceramic. Those are composed of the clay mineral, as well as cement and glass. These are the ceramic materials. Once again, aluminum oxide, silicon dioxide, silicon carbide, silicon nitride, and traditional ceramics, clay. That is almost same as cement and glass. With regard to the mechanical behavior, ceramic materials are relatively stiff, as well as metal, and strong. And strengths are comparative to the metals. In addition, they are typical, very hard. The surface is very, very hard. Historically, ceramics have exhibited extremely brittleness, not ductile. Lack of the ductility are highly susceptible of fracture, easy to fracture, However, new ceramics are being engineered to have improved the resistance of the fracture. But normally, ceramic is stiff and strong and hard but brittle. Furthermore, ceramic materials typically insulative to the passage of the heat and electricity. And are more resistant to the high temperature. So the ceramics can be used at a high temperature field. That is one of the important characteristics of the ceramics. Next, polymer. Polymer includes the familiar plastic and rubber. Polymer has two categories, plastic and rubber. Many of them are organic compounds that are chemically based on the carbon, hydrogen, and other non-metallic elements, ONSI. Furthermore, they have very large molecular structure. So, in the case of the metal, electron or atomic, very, very microscopic part is important. But instead, in the polymer, large molecular structure. When we compare with atomic, the molecular structure is very large. And the polymer is polyethylene, nylon, PVC, polycarbonate, polystyrene, and silicon rubber, so on. So the nylon, PA, PVC, PC, PS, and silicon rubber. These are polymers. These materials, polymers, have low density, whereas their mechanical characteristics generally similar to those metallic and ceramic materials. So polymer is not so strong. They are not stiff, not strong when we compare with metal and ceramic. However, on the base of their low density, many times stiffness, strength are per mass based on the comparative, those are metal and ceramic. So the low density means specific stiffness, specific strength is very high. Specific stiffness means stiffness divided density. So in the case of the polypropylene, density is lower than the 1.0, 0.99 something. Instead, metal, iron, has density is 7.8 something. So there is a big difference. So stiffness divided by the density means specific stiffness. In the case of polymer, specific stiffness is very high. That means lightweight and strong. In addition, many polymers are extremely ductile. So normally the polymer has a very longer failure strain and easily formed into the complex shape. Please think about the metal and ceramic. By using these materials, if we want to make a very complex shape, it's very difficult. But in the case of polymer, it's easy to make a complex shapes products. In general, they are relative inlet chemically and and reactive in a large number of the environment. One major drawback of the polymer is their tendency to soften, become have a low electrical conductivity and non-magnetic. Next, I will show some figures about the materials. So this is y-axis is density, and each materials, metal, ceramics, and polymers, plus composites, can be explained in these figures. So metal has a high density, and next is ceramics, and the polymer is very low, and the composite is also the low density. Density is related to the weight, so metal is heavy, and polymer is light. And next is stiffness. Metal and ceramic has equivalent stiffness. As I mentioned before, ceramic has almost same stiffness with metals. But the polymer is very low stiffness. So, but when we use polymer materials and fiber and then make composite materials, that is almost equivalent to the equivalent stiffness with metals and ceramics. And this is strength. Metal has the highest strength than the ceramics, and polymer is very low strength, but the composite has a higher strength than the ceramics, something. So the composite can make higher strength materials. Next is fracture toughness. Fracture toughness comes from the fracture mechanics concept. Fracture mechanics concept was started from the Liberty ship catastrophic fracture in World War II. So when we introduce a crack in the materials, and then crack start, initiation, and the crack propagate, by using that measurement, we can calculate the fracture toughness. So therefore, fracture toughness can be regarded as resistance to the crack. Metal has a higher fracture toughness, and ceramics has very low. Polymer is also very low fracture toughness. So if you introduce a crack to the ceramics, for example, China, and apply some load, easy break. That is a low fracture toughness material. And the polymer is also the low fracture toughness, but the composite has a very high fracture toughness material system. And this is electrical conductivity. Metal has a very, very high electrical conductivity because of the atomics, some micro scale structure, behavior. Ceramic and polymer has a very low electrical conductivity. But by using semiconductors, so this semiconductor's electrical conductivity is placed on between the metal and the ceramic and the polymers. So this photo shows the final products of the metal. Metal alloys from left to right, and silver wire, and wedding ring, and nut and bolt. These are metallic products from the metal. These are ceramic products. Ceramic scissors, ceramic cup, so on, so on. glass is also a part of the ceramic. Tile is also the ceramic materials for the building. You can see the China teacup also. This is a polymer cap of the bicycle, and the tire, rubber, and the fork, knife, and the water content. This is the plastic milk carton. So these are plastic. So for the density, these material, metal material, has a little bit heavy. If the teacup is very heavy, we cannot use that one. So therefore, this is not so heavy when we compare with the metal. And then these products are very light, we can say.